Next, if you go for homologous series of organic compounds, actually what do you mean by this homologous series of organic compounds? If you take series of organic compounds, for a series of organic compounds, if they differ by a member of CH2 group, for a series of organic compounds, if they differ by a member of CH2 groups is simply called as homologous series, and each CH2 group is called as individual homologue. And this homologue they have same chemical properties but different physical properties. This is because they have same functional group. Example, you can take plenty of examples to prove homologue. Suppose I am giving you C3H8, CH3, CH2, CH3. You are finding one homologue. You go for C4H10, so you get CH3, CH2, CH2, CH3. You are finding two homologues. Likewise, if you go for that means both of them they are differing by a member of CH2 group. Here you have one CH2 group, here you have two CH2 groups. So it increases in the geometrical progression. It increases consequently. Every time you see that the number of carbons are increasing, you find that the CH2 group also increases, and that is why these two are different organic compounds, but they are differing by a member of CH2 group. Here one CH2 group, here two CH2 groups. Suppose I am giving you one more example. This is A, this is B. Suppose if I am taking COH, this is an alcohol. If it is alcohol, alcohols have same, though they are differing in the individual homologue from one carbon chain to another carbon chain in alcohols, though they are having same chemical properties because of the same functional group, they differ in the individual homologue because of the increase in the number of carbon chains. Suppose I am taking CH3, CH2OH. You are finding one CH2 group. This is ethyl alcohol. This is. If you take CH3, CH2, CH2OH, this is propyl alcohol. But in ethyl alcohol we have one CH2 group. In propyl alcohol we have two CH2 groups. But what is interesting here is, here we have alcohol functional group and here also we have alcohol functional group. So we can confidently say that when you speak about the homologous series, the pair of organic compounds, they have same chemical properties because they have same functional groups, but they differ in the homologue series because for every new alcohol, for every new higher alcohol, you are finding that more and more number of carbons are being introduced. For every new carbon being introduced in a given chain, a new individual member, that is homologue member, is introduced. That's why they differ in the physical properties, but their chemical properties remains intact because of the same functional groups. So the next part of the discussion is nomenclature of organic compounds. In nomenclature of organic compounds, every organic compound properties every organic compound properties are known by functional group. By functional group, this functional group if it is principal functional group, we give secondary suffix. If it is principal functional group, if it is secondary suffix. If the functional group, sometimes if it is a substituent, we give it as a primary prefix. And for all hydrocarbons, that is alkenes and alkynes, their functional groups, alkenes, alkynes, they are given primary suffixes. So here, when more than one similar substituent arises in chain, it's given a numerical prefix. It's given a numerical prefix. Then number of carbons in organic compound is always given by a root word. If you take every organic compound, is made up of root word, primary suffix, numerical prefix,